So next we have a wonderful panel for you. I'll bring up some chairs so we can have a little fireside chat here. First up, we have Clément Pellegrini, CEO of Carnot. And we have Francois Tournesac from Implion. So please, have a seat. So we will have time for your questions. I've got a few kind of queued up for them. And then this will be the last session, and we'll have one more keynote, and then we'll be back to our tech demonstration. So thank you for sticking around. So I'd love just to start, please take some time to intro. I'll let you start, please.
Okay, thank you for the invitation. So I'm Clément Pellegrini. I'm the Chief Technical Officer of Carnot.
Wonderful.
And my name is Francois Tournesac, and I'm a co-founding implementer of Implion. And we are working with David to develop the consultancy business around cooling in Europe.
Why did you found Implion?
We found Implion because the match between the data center needs in reducing their energy and being able to be more efficient, and the customer is not yet there. The solutions are, there are a lot of various type of solution, and just like before it was said, every solution match a geography, a need, and what we're seeing now is a shift from the energy producing of the data center, because basically they're consuming a lot of energy, to be closer to the needs of the energy. So like what we're seeing, swimming pools, we're seeing also district heating, requesting for the heat. And the regulation from Europe will be very strong in order for everybody in the overall community to push this reutilization of the heat.
Wonderful. How about you?
So we decided to found Carnot 12 years ago because we were seeing a constant need of compute power, and that this need was growing. And so the energy consumption from this compute power was also growing. And on the other side, people are paying to get heated, to get more energy. And so the idea of Carnot was to be able to match the heat, to take the heat from the servers to heat the people, to be able to match those two different kind of business or individuals. And we decided to take an approach where we deploy the heat, the system, the IT system where the heat is needed. So we don't try to connect data center to buildings. We deploy data center inside swimming pools or inside district heating network, so we can value the heat at the exact place where we can value it.
Wonderful. And can you walk me through a little of the 12 years journey? Like you start with an idea, a thesis.
Yes, so the first product that we launched was a space heater. So that was like a space heater that you can find in people's houses. And the main difference is that the heat source was a CPU. So we created a space heater embedding IT servers. So we deployed this in people's houses. We pay for the electricity because we sell the server as a cloud computing platform. So on one side, people are paying to get cloud computing power, which will heat people in their houses. So that was the first product that we deployed. We are today heating more than 2,000 people in France with this system, and we did a lot of research and development, and we shifted to a new product that you can see in the back, and I invite you to come to see it at 4 p.m. This is a system with the same idea of being able to value the heat from IT, but to produce hot water. And so with this system, we can deploy it to swimming pool district heating network. And the product was designed to be able to do heat recovery. So it's very efficient. We have a 95% efficiency in the system, and we can produce hot water up to 65 degrees Celsius. But doing hardware is only a part of what we do, because when you deploy this kind of system, for the people who have this, they need the heat, so we have to make sure that the computers are running. And we deployed a cloud computing platform on top of it, which is able to distribute the compute workloads across all the installations that we have in France and in Finland. And for this, we have a lot of clients in the 3D animation and in the banking industry.
Wonderful. And how about you? Can you walk us through a little bit of your journey? I know Impleon's rather new.
Yeah, it's rather new. I mean, our background, David and I, is complementary. David is coming from more the Alfa Laval knowledge with the cooling, and I'm coming more from the Ethernet. As you've seen, Ethernet has been growing from 10 to now 800 gigs. So basically, this journey has been quite of a long and fruitful journey. But I've also worked with schedulers, and we had some question about scheduler just before with open source schedulers and into the AI. And then I found that basically working with David was a good combination between IT and needs and then the cooling system. So what we've been doing with David is working with all the vendors in order to really better understand their technology proposition, immersion, direct on chip, single phase, dual phase. There are a lot of propositions. And we've been working with end customers, district heating companies, and they are in fact in France, in Germany, in the northern countries, a few of them. There are less in the US, and these companies are also buying to swimming pools. For example, in France, there are 3,000 swimming pools, so this is a great market. And in fact, what happened is in September, the price of gas went rocket in Europe. So it was at time 10, which makes it now times 5, roughly. And therefore, a company went bankrupt in the swimming pool business because the price of gas was too expensive. The city, the municipality started to grasp the payment of the gas in order to benefit from better prices because cities have negotiated prices. And therefore, then we started to build consultancy program in order to advise the city municipality, which knowledge in liquid cooling for data center was rather thin, in order to advise them. And we came with a table of criteria that basically match the needs of the different areas, district heating, a swimming pool, and the various solutions. And by doing this, for example, we are working with the city of Meudon, and the city of Meudon is now to decide whether they will take this or this other solution. So today it's not a decision, but basically we've been studying Carnot, and we really understood that Carnot, very big benefit was to provide not only the system, the technology, the hardware, all what you see here, but they were also capable to provide the operation, the software, the monitoring, the scheduler with the exact time upload, not idle, so that you have the capability to heat the swimming pool to 30 degrees all day long.
Predictably. Yeah,
Predictably. And this is very important. I mean, at the end of the day, you want
Don't want to step into a cold pool.
You want the water to be warm when you dive into the swimming pool.
Yeah.
And there are a few solutions that match this type of system. You need to have a lot of expertise, not only in the cooling areas, in the IT areas, but you need to have the scheduler that will be predictable.
Mm-hmm. Wonderful. Thank you so much. And I'd be interested to hear you talk a little bit, Francois, about how you're seeing the movement of AI and HPC affecting your business.
So the business of AI is huge for us. I mean, because this will, in fact, bring a lot of the solution closer to the customer. And we've seen, the client server, the evolution towards the cloud. But I think now there's a major shift towards more of an edge data center that will be more locally present with the sustainability and the push from the European Commission. There will be a huge demand to make these data center optimized for reusing the energy. So the KPIs in which customer will be buying their IT is going to be shifting completely, and I think they need to have. And this is why Impleon is here. In fact, they need to have the help in order to understand how to do this. So AI is a key element. It will also shift the HPC quote-unquote business, which is very R&D oriented, to a more applicable solution. HPC often has a very good idea, but in terms of business, it's not that long term, because basically every time there's a new PhD coming with a new idea, and so you don't really see a business potential with HPC. But what you do with AI is it becomes mandatory for every business.
Did you hear that, Rich? AI is coming. How about you, Clément? How do you see it impacting your
Yeah,
business?
so we see a growing demand for HPC and compute power in the industry. We know from our customer that having the biggest infrastructure can be a game changer in terms of competition. So we see that that will increase during the next coming years. And we see that one of the big challenge is the cooling, being able to cool down the server, the TDP are going up. So being able to cool them down is starting to become a challenge. We see a lot of people who need to shift to immersion or to direct liquid cooling. And so we think that being able to do this is a good first step to being able to reuse the heat coming from the server, because it's easier to do heat transfer when you have a direct liquid cooling that with air cooling. And we also see that public policy are changing, and for example in France we know that in certain places when people want to build data center, they have to have a project where they will reuse the heat. Otherwise, they will not be able to build the data center. So,
because of those standards that are coming from
yes,
European
The regulation.
yeah, the regulation are coming, and we think this is important because data center have a huge impact on the earth for the construction. That's also why we deploy our system in existing buildings, so we don't have to build a data center. So that also reduce the footprint of the computation that are done on our platform. And another thing that we start seeing people think about is the water consumption. A lot of people are optimizing their PUE of their data center by using more water. But is it a good idea? Probably this is something that can be discussed. And with a system like the one we have, there is no water consumption. So we reduce the PUE at the lowest, and we have no water consumption, and we reuse the heat. So we think it's important for the HPC industry to be able to cool down the system and to go further than just optimizing the PUE of the data center. There is a next step after this, which is heat reuse.
Oh, I love it. And one last question before we open it up to the audience. Beyond heat reuse, do you see Cornell playing in the future of sustainability, and how is that going to evolve over the decade?
That's a good question. I think we will deploy more infrastructure. François was talking about edge data center. This is also something which is important. We see a growing need for local compute capacity. And so it's not easy to find space in a city, in a huge city, to make a data center. So being able to have locally distributed compute infrastructure can be something very, very important in the coming years.
Wonderful.
Yeah, we spoke about the regulation, but I think what people are getting to is that in the municipality, the concern about the data and the spending of energy is huge. And the politics are now really getting into this space because they know that they will not be re-elected if somebody comes with a building using 50 megawatts and not reusing this energy for the municipality will be banned. So as you know, the French do demonstrate a lot, perhaps not as much as the Brits now, but but nevertheless, we're not going to go in a contest like that.
Do you find at Implion that you're just tracking those regulations, or do you have any active influencing and trying to shape those?
So we're influencing because we're talking to the lobby in this area, and but you need to understand that because of the price of gas,
it's a natural force.
It's a natural force.
Yeah,
you know?
wonderful.
So it's a double effect.
Wonderful. Okay, do we have any questions from the audience for our panelists, please? There's a mic.
you said a lot about new regulations for data center. And we see that in France, in Germany, in Ireland, to make heat reuse. But what about district heating operators? Is there any regulations for them to shift from fossil fuel and prioritize the data center as a source of the heat?
Yeah, so in fact, the question is more back to the municipality, because usually the district heating are nominated by the municipality to basically deal with, as much the district heating, but it can be the water. So there are companies that are dealing with this. And I would say that basically we're back to the telecommunication area where, content and infrastructure was different. So today you will have content in energy that will be the boiler with gas. You will have geothermy with deep or surface geothermy, and you will have data center. And so if you want to have an energy mixed, and if you're a city, basically, you want to have this energy mixed, and you can also have solar, you can have, there are a lot of different energy mixed, and this energy mix will enable the people through different companies, district heating or swimming pools, etc., that will basically, the people from the community will benefit from these services.
Wonderful. Got time for maybe 2 more questions, please? Please, you can queue up. Yeah.
So can I be a bit controversial?
Yes.
So, we talk about edge. Will edge, who's going to own edge and who's going to operate edge? And what's it going to do to the core applications? So, there's people have been talking about edge, cloud continuum for a long time. What's your view on that? Should we shrink the core in order to grow the edge? Because let's face it, the history of computing has been distributed, centralized, and we keep going through this. Now we want it centralized and distributed at the same time. We can't afford it, really.
Yeah, so I think it's also a matter of what kind of computation you are doing. So some kind of computation needs to be done in a centralized data center, for example, but there is a lot of computation that can be done locally and that does not need to travel to be done.
So John, I think some of this depends upon the workloads that you're considering. If you a believer that we're going to wear something that accesses the internet, like a wearable and augmented reality, multi-reality type of device, we can't afford the latency of the use cases back to a centralized data center. So you have to do some level of processing at the edge, right, to speed up those transactions. But if you kind of think that we're just going to keep using the phones for perpetuity to access the internet, then maybe it works today.
Yeah, we tried to do some research on this in actually the fact of moving data around, the energy cost of moving data around. Yep. The thing that you need to factor in is that the infrastructure needs to be on first before you move. And actually the cost of moving it around is very, very small compared to the cost of keeping it on.
True.
So this is the problem with the core. If you keep the core on and putting things on the edge, then we are going to consume energy. What I would like you guys to look at is there's a decadal plan for semiconductors, and they're talking about this zeta instructions per second that we need in order to turn the globe in 10 years' time. And we are going to consume all our energy, so something's going to give at the end of the day, because unless we have a paradigm shift in the way we do computing, and that's an interesting one, the physical limits of computation. I don't think quantum will do it, but you want to speak, don't you? You want to ask a question.
Thank you, John.
Thank you, John. So, Carnot Computing, I think you have developed great things. I started Cloud and Heat 10 years ago with direct liquid cooling and heat recovery, and like you, we have these operations in various cities where we do heat district heating and these kind of things. But now we see in this earlier talk that the big data center researchers, they are looking at raising the air temperature maybe to 3 degrees, and they're using old servers. So when I started the company and doing heat recovery, I thought from the physics point of view, it's great, right? And nothing has changed. The same thing with Carnot Computing. But we are not hitting the market broadly, right? This is still a niche. So what do you think? What are the big obstacles? It's obviously not the physics behind this, because we are all clear that it's much more efficient, but there seems to be other obstacles that are even 10 years in the game. This is not picking up broadly, and we're still talking about how to improve, let's say, air-cooled data center, because Tesla is still planned right now and is still largely, mostly planned air-cooled, most of them planned not with heat recovery. So what are the obstacles from your point of view?
I'd love to hear from both of you. That's a wonderful question.
So when I started to work into this business of a cooling business, I really understood that the data center was a kind of a black box and a very complex area because everybody was protecting. You know, I've been working in the IT industry for 30 years, so to me, the world was more open than the data center. And in this data center, there are rules. And in the data center today, you have colocation. And the colocation don't own the server, and it's impossible to open the server. And basically, you cannot drive any other solution than air-cooled. So most of the business case of the data centers are based on colocation. And even in Europe, it's even worse because the hyperscalers are in colo. So basically, they are all dependent on colo. They're paying already part of the square meter for the cooling. So why would they cool themselves if basically they have the cooling for free? So the business model today is built around a solution which is only air. And this is why, you know, you've seen a business that is very difficult to penetrate. I've looked at this business. I say it's very difficult to penetrate. And when you have a problem and you cannot penetrate, you need to go around, you know, your surrounding strategy. I mean, you know, Napoleon did this for a long time, as you know. And so the surrounding strategy is basically to look for another opportunity, and from this opportunity to generate a business. And the swimming pool, even though it doesn't look very appealing to anybody today in this room because it doesn't look huge, the swimming pool is the surrounding strategy because basically it gives the opportunity to do something different. I mean, if you look, for example, the people from OVH, they had the idea to take a solution and put it into a factory and do the cooling inside because they were using less energy. They had this idea and they made it, and they have a business that is working, and they've been competing against the big guys, even though they were a very, very small bunch of people. So the surrounding strategy is the key to me. I mean, in the way to get there, and of course it doesn't look appealing, but I think it's a way to get in.
How about you, Clement?
Yeah, so I think one point is that we are in a business which at the same time we have to convince people to move to the cloud, which is not something easy even if you are only doing cloud computing. And at the same time we have to convince people that we can sell them heat. And these are different kind of people. District heating network are with concession for 20 years. You will not sell a cloud computing contract for 20 years to a bank. We would love to, but it's not possible. So I think it's part of doing innovation to be able to have more difficulty to convince people. But I think that may change because of regulation, because at some point people who will have to report how they do their computation, what is the carbon footprint of their computation, and also because of what François was saying. So.
Wonderful. Alrighty, this concludes our sustainability portion. Oh, Alan, one last question, please.
Yeah, my question was, so let's just pretend that you have a nice data center generating water. I've heard that you need it at 65 C, seems to be the optimal temperature. Can you elaborate on what you need out of the data center, or can it vary dramatically? So
the 65 C, it's the maximum temperature that we are able to produce with the system that we have today. So it will, of course, it will depend of what kind of CPU we embed inside the system. And one thing which is important is that the higher you get in temperature, the most valuable it's to be able to sell it. So, for example,
it's more valuable if it's higher.
Yes. Okay. So if you have 10 megawatts of heat at 30 degrees, it will not be interesting for a swimming pool or a district heating system. But having few hundreds of kilowatts at 65 degrees Celsius, this is something which is interesting for heat buyer.
Okay.
So there's a trade-off between the maximum you can put your CPU at, and today the 65 degrees is basically where you can still have working CPUs,
Yes.
and then you can have the heat from it. And the 65 degrees is very close to the 70 degrees, which is what you need for hot water in order not to get all the illness. So there's really a mean to the 65 degrees. I mean, it doesn't come out of the blue, and it will stay there. I mean, the 65 is a key. It's a minimum that is needed. If you look at other solutions, people are trying to get to the 65, but a lot of the solutions are today still at the 50, 55. Even if you ask OVH, we just mentioned, they've been having hot water from their data center for many years, but they've never resolved the hot water till now. I mean, they're just thinking about it now because it's becoming very popular. But till now, they have never sold their hot water to other people because they were just taking the value of the water for them was just in the cooling and in the integration of their data center so that they could benefit from factories.
Okay, thank you. That helps a tremendous amount. Just to say, I'm the technical lead, as probably most of you know, of the OCP HPC sub-project. And we are trying to radically re-architect the system architecture around this and include the ability to provide the water at such temperatures. So we're looking at direct water cooling over the processors, over everything really, try and get everything water cooled. And then actually have a control loop on the water cooling at a modular level so that you can control the speed of the water flow so you get 65C or whatever temperature you want out of every module consistently. Yeah. And then you could guarantee the water flowing out would always be of the temperature desired. Mm. So these are some of the radical ideas we're trying to do in the OCP HPC sub-project. We want all volunteers, so please come and help us.
So for your knowledge, Total in Pau, in the city of Pau in France, Total is the major Exxon or whatever, it's a fossil big producer. They have their data center in Pau. They all, when you visit the data center, they tell you we can heat up the whole city very easily. Right. It can be our business, no worries.
Okay.
Wonderful. Well, I'd like to thank Clément and Francois for joining our panel today. Thank you, gentlemen.
Thank you, Alan.
And we'll bring Lesia up to introduce our last keynote.